Okay, we're going to get started. Welcome, everybody. This is the Birds of a Feather session on plug-and-play multi-seat. There was some scheduling changes this morning. If you're looking for Josh's session on kernel scheduling, that's up in the Mount Hood room, and hopefully the people up there who might have come to see plug-and-play multi-seat come down here. We are going to do a bunch of demo stuff up here, so for anybody who's kind of way back in the room, come forward a bit so you can actually see what's going on here with the cables and stuff. There will be also an opportunity to walk up after the demo and take a look at everything in detail. Okay? So a little bit about myself. I actually was an author for the very first issue of Linux Journal. Wrote an article back in 1993 that got published in March of 1994 in the first issue of Linux Journal. And I've kind of had a career where I've bounced back and forth between the good guys and the bad guys. And depending on which set of people I associate with, who you define as the good guys and the bad guys is actually quite different. So just so you know. I mean, my philosophy about all this kind of stuff is, it's all about the users and it's all about moving things forward, and competition is good. And I think the competition from Linux has been very good for Microsoft. You notice that in things like, this cute little netbook that's $300. That would not have happened if it wasn't for Linux. And it works the other way too. I mean, I think there's, it's kind of an asymmetric competition between open source and closed software. And I think that pressure from the way Windows works and trying to win over the existing base of users is really good for Linux. So what I'm going to be talking about today is a very interesting scenario that could possibly apply to any operating system, but it's particularly compelling on Linux because of licensing reasons and technology reasons, and we'll go over that. So first off, how many people just know what multi-seat is? Please just raise your hands. How many people know what multi-seat is? Okay, so you really don't, or you do, and you're just not raising your hand. Okay, okay, well, good. I'm glad we got a few new people. So now, out of the people who know what multi-seat is, how many have actually set up a multi-seat config, 2 seats or more, of your own with your own hardware? Raise your hands. Okay, 20 years ago, which is interesting because it's been possible for a long time. And so then, how easy was it to set up a multi-seat config? Okay, we get the big thumbs down. It's quite difficult usually. So what defines multi-seat? Multi-seat is just where you're making use of the fact, first off, that Linux and any kind of Unix is, from day one, a multi-user system. And then you treat the independent devices attached to the system, clusters of displays, keyboards, mice, and maybe some other devices, as a terminal. So kind of from a hardware perspective, it just looks like a whole ton of devices connected to your server. But then in your configuration, you cluster those devices so that we treat one as a coherent terminal. This display goes with that keyboard, goes with that mouse, and I pop up a login screen on that. So the reason why I asked the question about people who've set up multi-seat in an existing environment is you've got a challenge. The kind of traditional way to set up multi-seat is you put a bunch of PCIe graphics controllers in this box. You got to crack the box open. You got to stick in a bunch of cards. You got to worry about bus types and a whole bunch of issues. And then you plug in a bunch of keyboards and mice, maybe via USB, probably via USB, because of course, with PS2, unless you do bridging, you'll need USB. But then the system has absolutely no way to know which displays go with which input devices. And so you have to wander into a territory that nobody ever, should ever have to wander into, which is the territory of the xorg config file, which in Linux is just, woe be to thee who, wanders into that world. And so what's interesting is the input devices on USB, they're plug and play. The system knows exactly where they've been plugged into in terms of the topology of devices. It's just the fact that the display device is often a wholly different bus that we kind of have lost some information. So what if we could get all the devices to simply be USB devices and then rely on USB's topology to say, well, there's this display, this keyboard, and this mouse, and they're all sitting off the same hub or a similar hub. Let's treat those as a terminal. And that's what we're showing here today, and I'll give you a bunch of details on it. So we're sharing the computing power of a central PC. So in some ways, this is kind of like a throwback, right, to the mainframe days or the central computer with the X terminals. But it's even simpler because the devices, X terms in concept could have been, just kind of a fixed function device. But the reality is you usually need to have a processor and a lot of memory and all kinds of stuff. What we're showing here today are just USB devices. There's no CPU in each of these. The only CPU up here is in that box, and these guys are sharing that computing power. So what are the size of the multi-seat deployments out there right now? If this has been around, somebody in the audience said set up their multi-seat config 20 years ago, right? If it's been around for a while and such, there must be a lot of deployments. Well, the difficulty of configuration has really been holding it back, but there's still a significant number of deployments out there. Hundreds of thousands on the Linux side and well over 1 million on the Windows side with some commercial solutions that kind of extend Windows. So they're significant markets, but they're nothing even close to what they could be if this were just easier so that anybody could grab any Linux box, any distro, just plug in a USB terminal and up pops another login. Wouldn't that be wonderful? And we're very close to getting there. So here's an example. We got, this is actually a setup down in my basement where we've got 4 terminals hooked up to a single server. And that server is actually this very netbook here, a 1.6 gigahertz Atom. So a very underpowered type device. And the single USB cable goes back here and then connects to a hub that's back there, which connects to each of those terminals. You can't really see here under the table, but all that's under the table is USB wires and power wires, nothing more. Okay. What are some other notable aspects of it? It's kind of a testament to the efficiency of Linux that I can even do this, that I can run 4 computers off of one extremely underpowered $300 netbook computer. Now, I cannot play good video on this. I'll get a terrible frame rate. I can't play 3D games, both because of processing power and because the actual X server that I'm running here doesn't support 3D. So there are limitations, but for all your regular apps, web browsing, all the games and educational software that comes in the educational version of Ubuntu, for example, they work great on this. And actually, you can't really see it back there in the corner, but for lacking for space here at our house, we've got a guinea pig cage back in the corner. And yeah, so when I first plugged in all these monitors and they popped on yellow, the guinea pigs were very surprised. You can do that? You can do that over USB? So there is a history here with this. This isn't something that's entirely new. What's new is how close we are to having all of this come together. So Dr. Quentin Stafford Frazier and others have been kind of promoting this model of shared computing, multi-seat computing for the third world for some time now. So if you go to ndo.org, you can find a bunch of great information. It's a vision for getting computers to reach the last few billion people on the planet. I'm fortunate to have a wife who writes, and she helps me copy edit presentations and stuff, and she asked me on this bullet point, so what happened to the other people? If you're a stickler on English, that's funny. So NDO has been working to kind of propagate this USB and network attached display model, very simple devices, for some number of years, and they've gotten some kind of great trials going in Bangladesh and South Africa and other places. One of their challenges was getting the chips that are necessary to make this magic happen, getting them into high enough volume production that the costs are able to get down low enough. And so what Dr. Stafford Frazier did is he actually started a for-profit company, DisplayLink, to go commercialize this network display or USB display technology, and that's a company called DisplayLink, which I'm now at my own company called Pluggable, but I was most recently at DisplayLink. And so he founded DisplayLink as a commercial arm, and now that's been successful in a sense. DisplayLink now has gotten these chips to where they've shipped over 1 million of them. It's probably approaching 2 million at some point here in the near future. So they're now getting at this kind of volume price points. And Dr. Stafford Fraser was also one of the original developers of VNC at AT&T Labs in Cambridge. So kind of that background in visual computing. That was a neat connection for me because I did a startup in the late 90s called cosource.com, which was a brokerage for open source work. And CoSource actually got the funding for the original tight VNC work that did the performance improvements for VNC. So that was a neat connection. So here you have a typical scenario. This is a picture from Indio. You just got a cluster of terminals connected around a single one, much like you're seeing here in the room today, right? So enormous benefits for the especially in an emerging economy, but even in any economy, that I only need to maintain a single box now. I mean, the cost of the hardware, yeah, that's important, but really the pain is if you've got a box to maintain and a hard drive to maintain and all the software and virus scanning and all that stuff on all those hard drives, backup, oh, what a nightmare. So here, you get down to a single box that you can admin, that you can back up, that you can maintain well. And these are all zero state, no hard drive, no data, nothing to go wrong. I can swap one in and swap another one in, and my kid or whoever's at the internet cafe can hop on there and log in just like nothing happened, right? So really, the cost benefits of the hardware are one thing, but the real benefits are kind of in the total cost of ownership area, and that's where it really makes sense for these internet cafes.
Question.
Yes?
Can we use Bluetooth or personal Wi-Fi to communicate?
Yeah, so the question was, can we use Bluetooth or personal Wi-Fi to communicate between the client and the server? So Bluetooth right now is about 2 megabits per second, and it's going to go way up when they have their ultra-wideband version, but that's not real yet. And then Wi-Fi, well, you're getting various speeds, but let's just say 40 megabits per second. So the USB cable has a theoretical maximum of 480 megabits per second. The practical is, let's say, about half that. So you're going to have about a 5-fold drop, at least, in bandwidth going to 802.11. And given how this setup, really its primary bottleneck, it has some bottleneck issues on the processor, but really its primary bottleneck is the USB cable. You're taking the bottleneck and you're making it even tighter. So you probably don't want to do that. Now, what's interesting is there actually are a whole host of devices coming out now using ultra-wideband. Or wireless, and so USB over ultra-wideband is called wireless USB. That runs at about half the practical speed of wired USB. And so, it's getting close, and that's kind of interesting. Like a setup like this, you might actually have the projector. Don't run these cables, and this terrible VGA cable, I lost my EDID because this cable is so long. So my computer was unable to detect the characteristics of the projector, which caused a bunch of problems. With wireless USB, you could have a straight wireless digital connection straight up to the projector, right? And no cables to attach, no cables to run from, I don't even know where the projector is here. Up there, they had to run a cable the whole way up there into the ceiling panel, down the wall, up here and up to here. So, yes, that technology is kind of coming together, and there's still a few more compromises for it. What's interesting from a Linux perspective or a driver perspective is it's all transparent. Things like wireless USB, software doesn't need to be aware of it. It's totally transparent to the software, and therefore you can plug one of these things into a wireless USB hub and try it yourself, and you'll find that for web browsing and a couple other things, it is absolutely fine. And so now you've got these interesting new possibilities because USB is so flexible of having your terminals be wireless USB distance away and no cables. Yeah, so good question. Yep. Yep.
Put stuff on laptops, and then all you're doing is syncing the videos. Video
Right.
on the machine because you really already pre-downloaded.
Right, right. Yeah, the question of the statement was, in classroom environments, they already kind of have a problem with video playback, where if everybody streams to each of the laptops over the network, they'll saturate the network. So, you introduce strategies to actually pre-cache all that video to sit on the hard drives of the laptops so that when they start, they're not actually pulling it off the network. Now, in this case, there is no hard drive, so every pixel that's showing up on these screens, there is a frame buffer, there is RAM on these. It's stateless, but there is memory, stateless memory. So, every time a pixel changes, some data went over the USB wire. That's the way it has to work for this particular type of setup. Yes?
So there is a slight problem in that, especially with many boxes exactly like that, there might be 6 USB ports, but there's only 2 EHCI chips inside. So you can only really run full video over 2 connections at a time.
Right.
So full video is its own little wax. But for anything less than that, this is just great.
Yeah. And so the statement was, in a lot of boxes like this, there may be many USB ports, but there's only 2 of the high-speed controllers, EHCI controllers, and therefore, you hit limits. We can talk a bit, if people are interested, a bit more about USB topology, but, each USB bus can support up to 127 devices, up to 5 deep on hubs. So you can actually, outfit a classroom here. You're going to, definitely be straining the bandwidth, but it's absolutely possible to outfit a classroom with a single box if you're willing to make a few, accept a few performance limitations. Yep.
These screens actually have graphics renderers inside them? Is that what it is?
Well, no. The way I have this set up right here, the graphics renderer is right in here.
And it is more than a USB hub.
Yes, it's more than a USB hub. So I'll go into a bit more of the demo a little bit later. But basically, what this is a USB hub, actually one USB hub with a graphics controller, USB graphics, USB audio, USB Ethernet, and then 4 extra, hub ports all in one device.
So what's bothering me now a little bit is
Yep.
that it's not really multi-seat, it's actually a thin client.
Well, in what way?
It's more than just USB going. I'm not trying to shoot it down, I'm just saying.
Well, it is actually just USB. Those are all USB devices. Everything that comes out of this device sits on the USB tree, and they're just devices waiting to be associated with whatever you want. It's just nice that you can also, I didn't point at audio, but the audio, you can, I don't have it set up here for the demo, but I've only routed the keyboards and mice, but you can also route the audio to match up with the correct terminal, so kids can have their headphones in here and get their headphone audio. And everything. Yes.
There are applications where the device is actually a pillbox, which is literally this big, which has only the frame buffer in it. So, take your pick.
Yeah, yep. And so the statement was, if you just want the USB graphics portion, they come in very small devices now, very small adapters. So here's an NDO deployment in South Africa. So this is, one of these kind of corner store, cell phone rental places that also offer internet access. A classic case to do this. So there's no hard drive, no processor associated with each of these terminals. So, and then in the home environment, it's the problem if you've got a family at all. It's that the kids and everybody fight over who's going to get access to the PCs. Well, no more fighting over PCs. You can just take your one PC, which is still the same, netbook that I've got over here, and have everybody use it simultaneously. And again, like I said, for the web browsing and the kind of games that come standard with the distribution, your kind of latency and lag and the feel of everything is very good. Linux is very good about prioritizing things like mouse movement and other things. You get that kind of snappy feel that you expect, even though the pixels are sharing this sharing this 480 megabit per second bus. And again, dirt cheap. Those pictures in my dingy basement at night are all this $300 Atom processor driving 4 USB terminals. For the boy that you saw there on the left, Wormix is a favorite app because you get to blow up things. You know, it's also good for, you know, doing up open office type application work. Right now, for this presentation, I wasn't able. I was going to actually have the presentation be on the first terminal and then have 3 more, and that EDID problem got in my way. I wasn't getting an EDID out of this long VGA cable. So, stupid VGA cables. You know, but I did actually create this whole presentation on this setup, right? So totally great for office applications. So stepping a little bit away from multi-seat, I mean, one of the things I wanted to kind of express is some of, you know, my own experiences in taking, you know, what had been a, you know, Windows and a little bit of Mac household and mixing in some Linux. I've run Linux a lot in the past, but, you know, like the rest of my family hasn't. You know, it is interesting. I mean, I think, you know, kids are very flexible and, you know, they actually enjoy something different. And so you sit a kid down in front of Ubuntu or any distro, Red Hat or Gentoo. The UI presents no issue. You know, they get all the, you know, they're flexible. They can take the basic concepts and extrapolate. It is tough from an app compat perspective, though. I mean, you know, as I think about an educational environment, I think about kids, I think one of our prime challenges is, you know, just how do we get the apps that people are used to running well enough on Linux? And so, you know, I think there's a lot of, you know, I'm kind of going through a process of experimenting with the various DOS emulators and with Wine for Windows emulation, trying to understand, you know, how I can express what the reality is here about, you know, how compelling is this or not in a real educational environment, which is what this, you know, I think, you know, is clearly the prime market for this kind of stuff. So, you know, in a way, a lot to think about. Okay, well, we kind of covered this a little bit, but, you know, just to compare and contrast, you know, if you're familiar with multi-seat, you know, with traditional multi-seat, you have PCIe graphics controllers physically plugged in your box. With USB multi-seat, they're all on USB. So with the traditional, you get higher graphics perf. On the USB side, you have some, you know, limitations on perf, which, you know, arguably will largely go away with USB 3 as you get 10 times the amount of available bandwidth on the bus, which will be very nice. Interestingly, they're kind of similar in hardware cost. If you take the cost of a PCIe graphics controller, let's say with 2 outputs, you know, $40 or something like that, it's about approximately equivalent to, you know, the $20 cost adder that USB graphics adds to a 7-port hub. So about in the same ballpark for initial hardware cost. Where the big savings are is in the total cost of ownership. You know, one of the reasons why multi-seat is not as prevalent as it could be today is because, and yet also has hundreds of thousands of seats out there, is because it's just really hard for an individual on a particular hardware box to set it up. But if you're doing a very large deployment on, like in an academic environment where you can pick one server platform and replicate it many times, it actually starts becoming doable. You know, so you know, in a number of countries like Brazil, they've done very large deployments of multi-seat, and it's basically that way. If they actually had a variety of different server types, they would get bogged down, but they you know, they try to avoid that. The great thing about USB multi-seat is it can work with anything. It's just plug and play. Now, there's some promise there that isn't reality yet in terms of some conflicts between the X frame buffer drivers, or the X server drivers. You know, right now with this multi-seat setup, I'm not actually running an X driver on the Intel graphics controller that's built into this box in the front. So I only have USB graphics controllers running. And of course, they don't have any real conflict with each other or with the PCI graphics controller. One of the wonderful things about USB graphics controllers is they have no legacy. All of these traditional graphics controllers, they all have that VGA block left over in them that's trying to decode I/O ranges, you know, for VGA. USB graphics doesn't have any of that issue. So, in fact, there's been a lot of troubles lately with recent distros where traditional multi-seat has been broken, and a lot of it has to do with VGA arbitration. And this setup today is running on one of those distros that has actually had, you know, some significant trouble, and it's able to do it because there are no VGA arbitration issues. It's just USB. We talked a little bit earlier about flexibility of cables. You know, with traditional, what you're going to have is out the back of that PC, you're going to have just a ton of VGA or DVI ports there, and you're going to plug in all your monitors to that. with USB, it doesn't need to look like that. I can have a nice little simple light cable coming up, to a device like this, which could be a hub, which kind of spokes out to a bunch of them, or I can daisy chain this particular type of device because it's got too deep of devices in it. It can daisy chain 2 of them, but there's other devices that might be able to daisy chain up to 5. And then we talked about all the, because USB is so prevalent, not only is it cheap, but people are routing it over all kinds of other things. It's a wonderful plug-and-play, point-to-point solution that people are now routing over over ultra-wideband with wireless USB and over things like raw Cat5 cable. So you can very inexpensively get great distances and yet keep all the plug-and-play characteristics of USB. So traditional is kind of limited per server to the free slots, whereas with USB it's limited by perf, so you can kind of go crazy and then just see where, kind of where the threshold of perf, cuts you off and says I can't add anymore, and then you have to add a server. But kind of physically your limits are much higher. Okay, so we have actually one seat running. So this seat here is running off this device, which again is no CPU, no storage. This is a $99 device that you can actually buy on Amazon right now. And so that we've got just a single USB cable that's heading over here to this computer. So what I'll do is take another USB cable. This one's going to this device here. And I'll try not to knock any of the power cords. And I'll plug this in here, and if Murphy doesn't visit me, we should see a terminal pop up there. So there we go. Plug, and up pops the terminal. And so here we're going to do the daisy chaining. So we're going to daisy chain this one into this one because it's just a USB hub, right? And up should pop our third terminal. So what I'm going to do in a few minutes is I'm going to actually show you the UDEV code that's doing all this. Is that going to pop up? There we go. Get all the angles right so you can see it. So single cable, nice light cable, nice cheap cable, totally plug and play. So what's happening here, just at a high level, just in general, is there are UDEV scripts which are detecting the arrival of these USB devices, and those UDEV scripts are going off and launching GDM dynamic instances to launch new instances of X and new logins. And it's that simple. And after the session, everybody's welcome to kind of come up and play with these if you want. I need to add some demo logins. So again, 0 state, no CPU, all USB. And these are the devices that are up here. Not much more power than a 7-port USB hub. It basically, the graphics device is actually able to operate solely off bus power. It does not actually need more than the 500 milliamps that's standard on a USB port. That's the same with the audio device, and that's the same with the Ethernet device individually. So collectively, you need a little bit more than the 2 amps that you might choose to have with a 7-port hub. I mean, this is probably borderline. But anyways, that's what these are powered off of. So there's at least 2 choices today for USB graphics. The leader is the company that I just came from, DisplayLink. Up until about 6 months ago, there were no open source drivers for DisplayLink, and there's just been an enormous amount of activity involving an enormous number of people over the last 6 to 9 months. So now there is actually a GPL kernel mode frame buffer driver. There's actually 2. This is Linux, of course. There's some user mode libraries. There's drivers for BSD. So suddenly here in the last few months, because of a bunch of things that have happened inside and outside of DisplayLink, there's a proliferation of software options. So if you go to displaylink.org, you'll find a wiki where there's links to a lot of the information about this stuff. There's also a company called MCT, has a solution which isn't selling. I don't know what the volume share is. it's probably like 80/20 or something like that. But they take a low-end traditional 2D graphics controller and put it out on the end of the USB bus, whereas DisplayLinks is a bit more of a custom solution that's optimized for USB. So both drivers are still for the adventurous. For example, the DisplayLink driver, there's a very early version that's not up to date with what I have here that's in the kernel staging tree for 2.6.31. Greg Hartman has been very involved and helpful in making that happen. But still a long way to go. This is definitely still for the adventurous at this point, running these drivers. Although, I mean, not that bad. I mean, the wiki pages are not long. They're like, compared to you don't have to do a complex Xorg configuration, because actually everything's kind of plug and play. The drivers, we added code to make them read the EDID and just set whatever mode the monitor's happiest with. And from an end user perspective, once you've kind of compiled and installed things, there's not all kinds of knobs to twiddle. It just works like you'd expect a USB device to. Now, as we've been kind of talking about, these are different than a traditional 2D, 3D graphics controller. Think remote frame buffer. All the rendering happens on the host PC side, and you're kind of remoting the final pixels. Now, what's interesting is this is actually really well aligned with the technology trends, right? We're getting more and more processing power on the host. We're getting bigger and bigger SIMD engines. There's maybe Intel people in the room, I don't know. In a year or two, we're going to have the Intel Larrabee, which is basically a whole bunch of Pentiums all strung together that are kind of halfway between a big multiprocessor and a GPU. So clearly we have an enormous increase in computing power in the host computer that things like graphics are perfect for those kinds of that kind of processing power, because it's highly parallelizable, the processing of graphics. And then of course you also have the progression of the bus. Everything that you see here today is demoed with USB 2, a bus that's been around for 10 years now, and limited to 480 megabits per second, even theoretical. Those limits will go up tenfold with USB 3, which, again, here at the conference, there's a number of presentations on that, and it's coming, fairly shortly. So kind of a different graphics architecture than you're used to, but one that's kind of compelling and kind of aligned with the progression of Moore's law. I said the drivers are for the adventurous. Also, the multi-seat setup, it's still the early days. I can talk about a couple issues when I do a quick walkthrough of the code if we have time, which I think we will. So I'll actually leave that to the code. So you can see it's integrated today with UDEV, but there's probably a lot more opportunities to do better. You'll see with the scripts that things are kind of in a raw form. For example, we handle arrival very well, but device removal, is totally messed up in the scripts today. Yes?
Do all the distros that have the latest UDEV already have support for this?
Okay, so the question was, do all the distros that have the latest UDEV already have support for this? No. This support is basically at this point sitting up on websites, and it's not in any of the distros yet. And that's actually one of the reasons why I wanted to come here today and talk here at the conference, because I wanted to start a dialogue not only about what's the right way to solve some of the various limitations that still exist with this, but then also what's the right way and the fastest way to get people excited about this and get this pulled into some of the distros. Because where this gets really powerful is when you just get that distro, you install it, any machine, you just plug in one of these and boom, up pops another terminal. And it's not that easy today. It's not super hard, but it needs to get that easy.
It's just changes to UDEV that need to happen, right? And the existence of a driver.
Yeah, so it's changes to UDEV. We'll go through the changes, and I'll kind of explain it. There's a couple tricks. One of them is this problem where current graphics, you can't run multiple X servers right now with a lot of versions of distros. There's problems. And they may be solvable with the right twiddling and the right magic, right? But I couldn't solve them. So for example, in this setup today, I'm not launching an X server on my primary graphics controller in order to avoid those troubles. So we got to work through those problems, and then we'll be good to go. because these are running wholly independent X instances. You know, this is not Cinemarama, this is not XR&R, these are wholly independent instances. And in particular, I'm very interested, there's a bunch of, you know, improvements and changes coming in this area of managing model seats. The work that's happening on Console Kit is probably at the center of it, and you know, want to get integrated with that stuff. Okay, so we'll take a quick walkthrough of some of the code just to give you an idea. You know, these are really just scripts. I'm not going to walk you through the actual kernel driver for the USB graphics. I'm going to start with the assumption that you've brought up the kernel frame buffer driver, and now you're just trying to configure multi-seat. So the focus is going to be on just multi-seat. Okay, how big's my terminal? Am I gonna? So again, you know, people at the back of the room, you're going to get penalized because you're not going to be able to read this text up here. So you know, if you can, head on up to the front of the room. So the first change that you need to do is GDM is the GNOME login, GNOME display manager, and handles a lot of the login tasks. And so the first thing that we do, and again, I don't know if you can see it there, but we need to do a custom gdm.conf. Well, I mean, I know that. Oh, because I'm not running the multi right now. So you know, this is what it is. It's basically a minimal gdm.conf that just sets up a bunch of options. You know, kind of the key ones are dynamic X servers are on for the daemon. That's the big one. For most of your distros, you're going to have dynamic X servers off by default. This implementation here relies on, you know, a set of functionality called GDM Dynamic, which I'm not sure exactly of the heritage of, but it seems to have come from Red Hat about 5 years ago or so, and I'm sure lots of people were involved. You know, it's this dynamic X server functionality so that we can use a utility that does come with most versions of GDM, or at least most versions up to recently where it has gotten broken, called GDM Dynamic. And GDM Dynamic allows you to launch and close X instances. Okay? We turn off flexible X servers, which is basically the Linux equivalent of Windows fast user switching. And then basically the rest of the stuff is just putting back in a few things that I wanted to keep the same, like the educational Ubuntu branding. Okay, so the other thing that this has done is I now have no default seat. So by default, what will happen is this machine will just boot up into a console. It's only when I start plugging in USB displays that you get any graphical login. So how does that happen? Because that's not here. Well, here's where it happens. It happens where it should, which is based on plug-and-play events. So in libudev, and there's a kind of a friendlier place to put these. You can simply add a udev script, which will go do some activities every time a device arrives or is removed. So this is it. This is the extent of the udev script that's required. Now, we're going to call one shell script in here, and I'll go over that. But basically, in short, the first 4 lines up there are just something to handle certain display link devices. I'm actually not even 100% sure that it works. I might need to tweak that a little bit yet. But basically, some display link devices come up first as CD-ROMs or other things in order to support easy install on Windows. Doesn't do any good for Linux. In fact, causes this problem where we have to work around it. But these devices don't have that problem. And in fact, you know, most display link devices don't. So that's a workaround for that. So then really the meat of it is down here in these lines. And you know, it looks like there's a bunch of junk here. But in short, anytime there's a frame buffer driver or something that exposes a frame buffer interface that's on the USB subsystem, we're going to first run a program which is going to go get the device number of the hub that USB device is sitting on. And then we're going to create a symlink which creates a name for that device out in the dev file system to say this is a seat sitting on that hub that we got back over there, and it's the display device for that seat. And then we're going to run a script to do something now with that information. And then it's the same thing with the mouse and with the keyboard. I have a device, it's sitting on a certain hub number, and so I'm then going to put that information in the dev file system. So then if you look out here in oh, I'm not running Multiseat. I'd have to do it over here. So on this system, which is actually running the Multiseat config, if I would do look out at dev USB seat, what I would see is a bunch of hub numbers and then whether there are keyboards, displays, or mice sitting off of it. And so the ones that have all three, a display, a keyboard, and a mouse, there you have a complete seat. And so then the USB seat script, which is a little long, will now go and look at the dev tree and see, okay, does a file exist for display, keyboard, and mouse? And if it does, I'm going to go take a template for what an Xorg config looks like for a DisplayLink device. And it's a very simple X config. I'll show it to you in a second. And I'm going to just substitute in the seat number. And then I'm going to launch with GDN Dynamic a new instance of X and a new login. And so really all the hard work happens right here in these two lines. Okay? And right now it's kind of difficult. There's not a lot of great documentation about sharing VTs and things like that. And so and there's a little bit of differences between versions of GDM and X. So I'm very eager to kind of get this stuff integrated into the distros so that all these annoying differences that you could lose a few days on for each one, they just get done when the distro is done, and it just becomes a no-brainer for the actual end users. So there's the script. We're going to now show you the Xorg config file that we use as the template. Well, it's a little long, but it's simple. So a bunch of server flags that are necessary to get multiple X servers working right now. The big thing is there's been all this work lately to make X easier by having the X server automatically grab all the keyboards and mice, your primary X server. Well, you don't want that here because you actually want to control and say exactly which X instance all those keyboards and mice and stuff go with. So every one of these options up top is essential, at least on Ubuntu 8.04 and 8.10 and 9.04, to get this working. In particular, the turning off auto-add devices and auto-enable devices. So then we pick up the place where the DisplayLink X servers are. We define a device, which is very simple. So this is, this option fpdev just says go use this frame buffer out in the dev file system, and we made this very nice symlink in the script that you just saw previously, the UDEV script, to put that out in dev USB seat, whatever the seat number is, and the display for that seat. Yes?
If you're using the kernel frame buffer driver, why do you need to set that?
I'm sorry, could you speak? Actually, can you go ahead and use the mic there? Actually, I think that's on.
Just wondering, if you're using the kernel's provided frame buffer from the kernel driver, why do you need a separate X driver?
Okay. Well, because you might choose to do applications that go direct to frame buffer, but I do want to run X here.
Well, there's an existing frame buffer driver in X.
Oh, right. Okay. So why does this setup actually use a custom DisplayLink X server rather than the generic one that works with any frame buffer device? Very good question, and actually I said earlier that there's actually two DisplayLink kernel frame buffer drivers. Well, the one that was originally written has its own X driver. There's been a new one that's just popped up in the last 2 weeks, and in fact the excellent developer who wrote it is actually here at the conference, and I hope to meet him for the first time. It does use the standard X server that just uses the regular frame buffer. So there's no reason. It just wasn't done that way originally. And I'm not yet running the new X server. Okay, good question. So then we similarly define the input device. We've put it out in a very kind of easy, obvious location. And then the rest is just really boilerplate, right? We don't have any Zinorama or any kind of complexities here because each is just its own screen that takes up the whole screen. So there you go. That's it. You know, it's not a lot of stuff, and I would love to, you know, again, you know, this gets very powerful once it's just simply there in the distro. And especially if we can resolve the issues where I can just be running, you know, my normal graphics, primary graphics controller as I would be, and then just add the USB display and it just works without affecting my primary thing. I don't know exactly how that's going to happen. I mean, I think there's a lot of discussion that has to talk about that because, you know, today if I, you know, plug in 2 keyboards to my one system, okay, well my assumption is that one primary X server is going to treat a key press from either of those keyboards as something that it should be listening to. That needs to change for this case. So, you know, one of the things I think that's worth exploring is that we key off plug-and-play IDs. So if you have a device that from a kind of a USB product ID perspective is something that is intended to be used as a terminal, when it arrives and anything connected off of it arrives, we treat it as a terminal right from the get-go in a plug-and-play fashion, nothing to switch, nothing to configure. And I think ultimately that's the right thing to do. Yes?
Is there as far as you know, a certain length of this USB cable where you start to get problems on USB 2 and will that change?
Right, okay, so the question was about cable length. Is there a certain length of cable where you start to have problems? So in theory, the cable length limit on USB 2 is 5 meters, so about 15 feet or give or take. In practice, most of the USB cables you see are about 4 feet. You need a very high quality cable to go out that whole 15 feet. It needs to be well shielded, but there are some that are sold, especially at the 10-foot length. They're cheap and they work and there's no limitations. It's basically a shielding issue. And then you could chain 5 deep on powered USB hubs. So you can actually go out 30 meters, or no, 30 feet. All right, I'm not doing my math right here. So 15 meters, sorry. Yeah. So you can go out 15 meters, you know, so 45 feet in theory. And in fact, one of the things that has become very cheap and common right now is a simple USB extender device, which is actually kind of a one-port hub that's powered off of USB itself, which kind of retransmits the signals and gets you a whole other cable length. So there's a lot of good options to get you out to that full theoretical depth. Now USB 3, as far as I understand it, is actually shrinking that cable length a bit. It's going from 5 down to 3 meters. So a little bit of loss of cable length. As we gain 10 times the throughput, we're going to lose a little bit of cable length, but that's probably fine. Any other questions? Yes?
If I plug in 2 mice, then they're in parallel. And so each person can point at the screen using his own mouse saying, no, over here.
Right.
Over here. Can you do that on those devices?
So the question was, if I have 2 mice, and I do actually want to assign 2 pointers to the same X screen, and they're independent pointers, kind of like multi-touch, is there a Linux name for the multiple pointers? I don't know. Yeah, you know, I think the answer is you can see the scripts here are not long or complicated. There probably is a way to do it.
It's not even multi-pointer. It's the same pointer. It's just that each mouse drives the same pointer.
Oh, right. Each mouse drives the same pointer. Yes. That would be very easy to modify these scripts to do that. Yeah, today these scripts assume you have a single mouse. There's no need for them to have that assumption. They could have mouse 1, mouse 2, mouse 3.
In the educational case, where you have, please come help me, so the person walks over to the same terminal, and then the student says, right here, I don't understand. And the teacher says, well, using a separate mouse, so they have to trade hands
Right.
to move, says, well, the answer's over here.
Right, yep. Well, and you could even kind of get wacky, you know, because the information, and I'm sorry for the people watching on the tape to not restate all that, but basically it was, you know, a teacher helping somebody with their own independent mouse. You could also even potentially, the information is in your computer to clone those displays. You could even potentially have a teacher say, okay, well, give me that student's terminal, and then it'll start sending the same screen data, whatever it is, for that terminal to the teacher's terminal, and then the mouse pointer controls that. So, you know, all of those things are not huge leaps away, but they're work that's not done. I mean, somebody would have to, but in a sense, it's high-level configuration stuff. The building blocks don't need to change in fundamental ways to enable that. Somebody would just need to go do some kind of configuration work to make that happen. Yeah. Okay, any other questions on the scripts and code we walked through? Yep.
You don't have any handling for audio.
Yes.
Plans for that, or is it?
So the question was, you know, and you noticed I didn't have any handling for audio. Is there any plans for that? You know, I kind of come from a graphics background, so I wanted to tackle graphics first. Yeah, audio is possible. Actually, if you go and look out at the kind of the traditional multi-seat case, you'll find instructions for handling audio. You know, it's Linux audio, so there's a whole ton of problems. You basically need to bet on one audio system like ALSA. But you know, given that, yes, it's totally possible to you know, have the seat also include an audio device. And if anybody wants to kind of submit a patch to these scripts to you know, to show how to do that, it would be very, very welcome. Or you know, at some point it'll probably happen on its own. Everything that I walk through here is at this URL. If you want a shorter version of this, just go to displaylink.org, go to How To, and then go to Multiseat, and you'll get everything that I just walked through here, plus kind of, you know, end-user-ish kind of instructions. So, almost time for hands-on. Okay. Well, let me do a quick pitch. So, these devices I'm actually selling. So, if you go search on Amazon right now, I think you'll not find it, but you will in the next few days actually see this device. Just search on pluggable. And, you know, we've already talked about it a bit. You know, the concept here is, you know, our computers are really getting turned inside out by the fact that these external devices are getting so interesting. I almost want to have a computer which is just a processor and some RAM and have everything else sitting outside of it, storage and stuff. And in fact, one of the things that I'm eager to get working in the next few weeks or months is taking one of these and pairing it with a Shiva plug, if anybody knows about those, which is just an ARM processor with a network tap, which you won't need necessarily here, and a USB. And now you have a complete computer with these two pieces, and I think if I got a day or two of time, I would, you know, I'd have that working. Some people have already done the good work to, you know, fix a couple of the bugs in the drivers to make sure they work on ARM. So all the basic building blocks are all there. Yes?
Personal involvement. Are you the one that set up the UDEV stuff?
Yeah, so the question was, what was my personal involvement? Yeah, I did all the UDEV stuff. Basically, everything we just walked through there, I did that portion. And I've actually, you know, coming out of DisplayLink, I was actually involved at DisplayLink with the, you know, with the open source work there for the graphics driver too. You can get a good sense of it if you go to the, you know, displaylink.org's list. You know, I'm kind of the technical guy who coordinated most of that stuff.
So you're not really personally interested in multiple video cards to make this type of solution?
Right. Yeah, exactly. Yeah. So the question was, I'm not personally interested in multiple video cards. Yeah, that's a bias for me in a sense. You know, I'm interested in plug and play stuff. You know, USB stuff. You know, so yeah. So if I maligned the PCI, you know, graphics card multi-seat case, that's the reason. It's because I've got an inherent bias. Okay. So I think we don't actually have time for this, you know, but I am interested, I'm very interested, in fact, it's the whole reason why I'm here. You know, as you see this stuff, you're sitting here, you're thinking about things, you realize, oh man, these guys, they're missing this opportunity to do this one small thing, which would be such a better way of doing it. You know, please, you know, come talk to me afterward, talk about those things, or, you know, hop onto the community at displaylink.org, which is basically the way to connect with me. Just, you know, anybody is welcome on the wiki to add, you know, any of your experiences, any of your ideas. You know, basically, it would, again, I mean, not to restate things too many times, but where this gets very powerful is when it just works out of the box with the distros. That's where multi-seat goes from being something interesting, fascinating potential, but can't take off, to something that could take off in a really surprisingly huge way. And we're so close to getting there. So thank you very much, everybody who came and listened. It was great to have this opportunity to talk to you. and everybody's welcome to kind of come on up and try stuff here. So thank you.